Hi, so in this video we're going to be talking about how to make a percent bar graph, and we're going to be using relative frequency as well. Alright, so let's get started. You can see at the top it says that categorical data is data that can be divided into, in the blank there we're going to put categories, which are based on the attributes of the data. So you're going to be looking at information or data that's been collected, and that makes sense to divide into different types or categories. You can summarize categorical data using the mode. So we're going to be comparing the categories, seeing which one has the most in each category. Okay, so relative frequency is something I referred to a little earlier, but it's a term you're going to be hearing used with percent bar graphs. It's the ratio of the number of times a category is represented to the total number of pieces of data, and it's often expressed as a percent. So frequency is just how often something occurs, and it's relative frequency because it's the how often it occurs compared to the other categories. All right, and usually we're going to be changing this to percent. So a relative frequency table shows the percent or percents of values in each category. And then if you take that information and put it in a bar graph, it's called a percent bar graph. And it'll show the relative frequency of each category in a single bar. So what makes the percent bar graph a little different maybe than the other bar graphs you've done before is that it's just a single bar, compared to like a regular bar graph that has multiple bars. All right, so in this first table, it shows the number of students that play each sport. So you can take a look at those. There's 6 sports. It says to summarize the data using the mode and then represent the data in a bar graph. All right, so if I look at each of the sports, I can see that the one that most students play is football because it has the highest number of students. So I'm going to fill that in. More students play football. So football is the mode. The second most played sport among the students would be soccer. It has 33. And then if I look at the number of students that play football compared to the number of students that play basketball and baseball, you can see there's definitely more football players than basketball and baseball. I can see that there's the same number of basketball and baseball players. But football is actually twice as large as basketball and baseball. If I multiply 23 times 2, then I get 46. All right, so now I'm supposed to take that data and put it into this bar graph over here. It's already divided, or the axes are already labeled for me, so I just need to draw the bars. Soccer is 33, so I'm going to start with soccer and go in between 30 and 36. Basketball is 23, so not quite as high. Volleyball is 16. Football is 46. That should be the tall one. Basketball is 23, so that should be the same height as baseball, or basketball and baseball. Sorry, my bars are not very straight. And then tennis would be 8. And notice, that the bars are not touching because this is a regular bar graph. It's only in a histogram that the bars touch each other. Okay, so moving on. Exercises 1 through 3 refer to the table, this one here, which shows the number of types of animals treated at an animal clinic, summarize the data using the mode, and then interpret its meaning. So again, I'm going to look at the different categories of animals. So there's dogs, cats, farm animals, and caged pets. I can see that dogs were the most treated type of pet, and caged pets were the least treated. So I'm just going to use that to write a statement about the data. So dogs, let's see, there were more dogs treated. So dogs are the mode. I could say that there were twice as many dogs treated as farm animals, since 2 times 2 is 4. There's really no wrong or right answer for this one. You're just going to be looking at the data and then writing some type of statement involving the mode for those. All right, number 2, it says to determine the relative frequency or percent for each animal and then round to the nearest tenth if necessary. So I'm going to come over to my table. I need to figure out the percent of each of these. Remember, percent is really comparison of, or a ratio of the part to the whole. So I know there are 4 dogs, but what's the whole in this case? Well, that would be the total number of animals. So the first thing I need to figure out is how many total animals were treated. So I'm going to add up these numbers. 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So I can make a fraction out of this. I know that there 4 out of 10 dogs were treated, but I want to change that to percent. So I'm going to have to remember how to use FDP for this. So in case you've forgotten, to get from a fraction to a decimal, I divide, okay? And then I will eventually change that to percent. All right, so fraction to decimal, I can use top in, bottom out. So I'm going to do that up here. 10 won't go into 4, add a decimal and a 0. 10 will go into 40 4 times with nothing left over. So I've got my decimal, 0.4, but I still need to change it to percent. So remember, to go from decimal to percent, I'm going to move it 2 places this direction, so 2 places to the right. In this case, I'm going to have to add a 0 to move it 2 places, so this becomes 40%. All right, I'm going to do that for each of these numbers. So now I'm going to divide 3 into 10. The whole will stay the same. Oh, sorry, wrote that backwards. 10 into 3. Let me just start over. Can't divide 10 into 3. 10 will go into 30, though, so I'm going to add my decimal into 0. 10 will go into 30 3 times, so that's 0.3. If I move it 2 places now, I get 30%. And then for farm animals, I'm going to start with 2 over 10, so 10 into 2. Add a decimal and a 0, 10 will go into 20 twice, and then move it 2 places, so that becomes 20%. And the last one will be 1 out of 10. So if I divide 10 into 1, I'm going to add my decimal, my 0, 10 will go into 10 once, move it 2 places, and that becomes 10%. All right, so once my table is complete, then I'm going to transfer this information now onto this bar graph down here. And so this is what we call a percent bar graph. You can see that's just a single line. And this one has been divided into 10 sections. So each of the sections, a percent bar graph will go from 0 to 100 all the time. And so each of these sections is worth 10%. So when I want to represent dogs, I need 40%. That's going to be 4 of the rectangles here. Now, most of the time when people do percent bar graphs, they use different colors. I have one color right now, so I'm just going to do different patterns to show the different percentages. So this one I'm going to use lines, horizontal lines. Okay, and so I can call this dogs. It's 40% because it's got 10, 20, 30, 40%. All right, cats is 30%, so that'll be an additional 3 rectangles, and I'll do diagonal lines for this one. And call it cats. And farm animals is 20%, so that would be 2 more rectangles. How about polka dots? And the last one, 10%, is going to be my last rectangle here. Oops. And I'll do zigzag. This is my caged pets. So again, if you were doing this, and probably like as a business, if you were going to use this, you might use like red for dogs, yellow for cats, and so on. Also notice that a percent bar graph is completely full, and you want to make sure that when you find the percent in your table, your relative frequency table, that all your percents add up to 100, because you're going to need to fill in the entire bar. So ours did, so we were good. And this is real similar to how you do a circle graph, which you have probably seen before. Circle graph or pie chart, whatever you called it in elementary school, works the same way. So you're starting with the circle, and you need to divide it into pieces, or into pieces of pie, right? And then each of those pieces will have different sizes based on the percent of the pie that it covers. All right. So if I were going to do this, use the same information on this circle chart, because of the numbers I got, 40, 30, 20, and 10, it's easiest to start by dividing my circle into 10%, because then it's easy to figure out how much to use for each one. So 10%, I'm just going to have to guess. We're at 10. I'm going to try to divide my graph into 10 pieces. And you can see it's not exactly right, but it's pretty close. All right, so then if dogs are 40%, I'm going to use 1, 2, 3, 4 pieces of pie. So 40 is not quite half. This would be my dogs. My cats are going to be 30% again, so something like this. And then farm animals are 20%. And then lastly, I have 10% caged pets. Okay, so same idea as the percent bar graph. Again, the percents all need to equal 100 when you're using your circle graph or pie chart. All right, and then in this last problem, we're going to be using the information we get from a percent bar graph to answer the question. So this says the percent bar graph shows the percent of each type of trading card that's in John's collections. If John has 400 cards in his collection, how many of these are baseball cards? All right, so if I look at my key down here, I can see the baseball is this white space right here. I can see again this percent bar graph goes from 0 to 100%, which it should. This little space here is hockey, and then the darker space is football. So since I'm trying to figure out how many baseball cards there are, I need to know what this percentage is. So it looks like baseball goes from 0 to 60%. So there are 60% of his collection would be baseball cards, but I want to know how many cards, actual cards, that is out of 400. So this is one of those times when I'm going to use the percent proportion. Remember, that would be part over whole equals percent over 100, in case you've forgotten that. And then I'm just going to use that proportion to find the missing number that I'm looking for. So I always start by drawing boxes. That helps me remember the 4 parts. One of them is always 100, and my percent always goes above the 100. So in this case, that would be 60, because the baseball cards are 60%. And then I needed to figure out, is the 400 the part or the whole? Well, 400 is this total collection of cards, so that's going to be the whole. Part is what I'm looking for. Then to solve this proportion, you multiply cross products. So 400 times 60 is what I want to start with. 400 times 60. I'm going to start with a 0. I'm going to get a lot of zeros here. And then start with another 0 in the second row. 6 times 0 is 0, 0, and 24. When I add these up, I get 24,000. Then I'm still not done, because I need to divide now by 100. So if I divide 100 into 24,000, it'll go into 242 times. When I subtract, I get 40, bring down that 0. 100 will go into 400 4 times. Subtract and bring down that last 0. 100 will go into 0 0 times. So the solution to this problem is that there would be 240 baseball cards in his collection. All right, so that's percent bar graphs. Remember, you're really just turning a table of information into percent. Okay, that can also be called relative frequency, and then transferring that information into either a regular bar graph, as we did here, or a percent bar graph, which is a single bar down here, or into a circle or pie chart graph. graph too. All right, thanks.